Friends, welcome to the video. In this video, I'm going to talk about the Vernier Calliper, which is a tool used in industries for precision. For example, it is used for the diameter measurement of any cylindrical object. Because machines work on very small measurements in the range of micrometers, this thing is achievable using a Vernier caliper and micrometer screw gauge. And another thing is, if there is any small measurement error, it can cause machine failure or sometimes a deadly disaster. As you can see, here is a labeling diagram of a Vernier caliper. Now let's understand all the different parts of the Vernier caliper. First of all, the main scale, which measures everything in the range of millimeters. Now, the Vernier scale, which is an actual measuring tool, we can also be seen as the heart of the main device, used for actual precision measurements. Then the outer jaws, which are used to measure the outer dimensions of any object. And the inner jaws, which are used to measure the inner dimensions of the object. The depth bar is used to measure the depth of any object. A locking screw, which is used to lock the measurement. The adjustment screw is used for sliding the Vernier scale to the suitable measurement. Before actual measurement, first of all, you have to find the least count. So how do we find it? It is a simple ratio. Ignore the least count in the previous image. It was wrong. Now to find the least count, identify the smallest division on the fixed main scale, typically 1 millimeter. Next, count the total number of divisions on the sliding Vernier scale, usually 10, 20, or 50. Divide the former by the latter. For example, in our case, 20 division Vernier scale, the least count is 1 millimeter divided by 20, which equals 0.05 millimeters. If you don't know the least count, your reading is mathematically meaningless. But knowing the LC is only half the battle. What happens when the instrument lies to you before you even begin? Now I have opened the simulation here. Website link in description. In this particular case, let's set the least count of the Vernier caliper to 0.05 millimeters. First of all, go to Settings, then in Unit select Metric, then in Least Count select 0.05. As you can see in the Vernier scale, there are 20 divisions. So the least count is 1 divided by 20, which is equal to 0.05 millimeters. Now, to get an understanding of the Vernier caliper, first of all, the zeros of both the Vernier scale and the main scale should coincide, as you can see here. It means that our caliper has zero error. We will discuss about errors in the caliper afterwards. Now, let's consider a random measurement for understanding purposes. So I have set here a random measurement by sliding the Vernier scale, as you can see. First of all, you have to see where the zero of the Vernier caliper is. As you can see, it is between 10 and 11 millimeters. Take a small value of 10 as our measurement. Then observe which division of the Vernier scale coincides with the main scale. As you can see, the 9th division of the Vernier scale coincides with the main scale. So simply multiply 9 by 0.05, which is the least count of the Vernier caliper. You will get 0.45. Now, simply add 0.45 to 10.0. The final answer you will get is 10.45 millimeters. It is as simple as that. Here, the formula I have used is main scale division, MSD, plus least count, LC, into Vernier scale division, VSD, plus error. Here, in our case, 10 plus 0.05 and a 9 plus 0, as there is zero error in our case. To verify your answer, go to Settings mode, and then Training if it is not selected as the default. Now, let's change the least count of a Vernier caliper to 0.02 millimeters. As there are 50 divisions in a Vernier scale, 1 divided by 50 gives us 0.02 as the least count. Now let's take a random measurement. Here, 0 of the Vernier scale is between 4 and 5 millimeters. So take 4.0 as the first measurement. Now, as you can see, the 14th division of the Vernier caliper coincides with the main scale. So multiply 14 by 0.02. You will get 0.28. Now, add 4.0 to 0.28. The final answer you will get is 4.28 millimeters. And there is zero error off course. Now, to understand the error, I've visited another website. Link in the description. Here you see a vernier caliper with a least count of 0.1 millimeter or 0.01 centimeter. As there are 10 divisions on a vernier scale, 1 divided by 10, so LC is 0.1 millimeter. Here on this website, all the measurements are taken in centimeters, and on the previous website, we have taken all the measurements in millimeters format, so don't get confused. There is one option to set an error. Let's set the error to -2. To find the exact error, here, it is a negative error because 0 of the vernier scale comes to the left of the main scale. And for that, you have to see which vernier scale division coincides with the main scale. Here, as you can see, 8th division of the vernier scale is coinciding with the main scale. So multiply 8 by 0.01, you'll get 0.08. Now subtract 0.08 from 0.1, and you'll get 0.02 as a negative error. Let's take a random value. As you can see here, the measurement is between 1 and 1.1 centimeters. Take a small value, 1 centimeter. And you can also see that the 5th division of the vernier scale is coinciding with the main scale. So multiply 5 by 0.01, least count, you'll get 0.05. Now add 1 to 0.05, you'll get 1.05. Now we get a negative error of 0.02. So to eliminate it, add your measurement 1.05 with 0.02, so the final answer you will get is 1.07 centimeters. Now, for positive error, set 0 error to +2. Positive error because the vernier scale 0 is on the right side of the main scale. And as you can see, 2nd division of the vernier scale is coinciding with the main scale. So now multiply 2 by 0.01, you will get the positive error of 0.02 centimeter. No need for further calculation for positive error. Now adjust your vernier caliper for example measurement. Here, our example measurement is between 1.2 and 1.3 centimeters. Take a small value, 1.2 centimeters. Now, as you can see, 7th division of the vernier scale is coinciding with the main scale. So multiply 7 by 0.01 and you'll get 0.07. Now add 1.2 to 0.07. You'll get 1.27. To eliminate error, subtract the positive error from your measurement. So 1.27 minus 0.02, you'll get 1.25 centimeters as the final answer. I hope you all understand the vernier caliper, how to use it, least count, errors, and the shortcut method that I have used in this video. So that's it for today's video. Thank you so much for watching the video.